Hi, and welcome to our pre-recorded Master of Advanced Study information session. My name is Philip McMullen, and I am the Director of the Master of Advanced Study programs here at UCSD's Jacobs School of Engineering. Given the shelter-in-place order in which we all find ourselves, we have had to improvise on how we deliver our information sessions. I would much rather we were all in a room together, live, with real-time discussion and Q&A, but unfortunately, that is not an option at the moment. In the interest of efficiency, I am providing this pre-recorded webinar of my normal presentation. You can watch the whole thing or skip forward to learn more about a specific program. In addition, we plan to hold some live program-specific Q&A webinars with some of the faculty, and hopefully, if they're available, a few alumni to help answer your specific questions and learn more about each program. So let's get started. What I'm going to cover today is some information, general information about all the programs, the application process, schedules, costs, that sort of thing. And then I will drill down more into the three programs: architecture-based enterprise systems engineering, wireless embedded systems, data science, and engineering. So if you live in San Diego, you probably know about UC San Diego, but maybe not the School of Engineering. We are proud to be one of the top 10 engineering schools in the nation. We have keep some pretty good company in that group: MIT, Stanford, Berkeley. We have over 230 research active faculty and a strong commitment to serving the needs of industry. As you can see from the slides, we have 6 different departments in the School of Engineering. In addition, partnering with us in the MAS program is the San Diego Supercomputer Center, which is based on the San Diego campus. So one of the questions I often get is, I'm not familiar with the MAS degree and how is it different from the MS degree? So a little background, a little history. The MAS programs were started by the UC system back in 2001 as sort of a sister degree to the traditional MS degree. They are taught by the same research active faculty with the same academic rigor. So a couple things happened. So UC realized that not everyone who wants to pursue a master's wants to quit their job, forego income for 2 years, take out student loans in order to pursue a master's degree full-time. Also, most traditional MS degree programs are feeders to PhD programs, and probably 90% of the individuals who pursue a master's do not plan on going on to get additional education. So some of the unique characteristics of the MAS degree: delivery, timing, and method allows for working professionals to continue their full-time job while pursuing a master's at the same time. A stronger emphasis on practical application of the knowledge along with theory. All of the MAS degrees have a capstone project instead of a thesis. The capstone is a critical part of the learning and allows students to apply the knowledge to real-world applications. Our programs are interdisciplinary, so all the programs have at least 2 different academic departments who partner, and it allows you to bring in new fields, new curricula that a traditional MS degree would not cover. We have smaller class sizes, which allows a better ratio of student to faculty and TA support, and it's assumed that this will be a terminal degree, meaning that the majority of the students will not plan on additional degrees. If you are considering a PhD, I would suggest you schedule a time with me for us to talk on the phone, and I can talk more about what that would mean. But all of that, bottom line, at the end of the day, you will graduate with a master's degree from one of the top engineering schools in the nation. I have stopped adding to this list because the font would be so small that no one could read it. So we have well over 200 companies where individuals have come to pursue a master's degree in our MAS degree program. We even have individuals from the Bay Area who have come down to pursue a degree here. So information that's relevant to all of you for all the programs about program requirements. First, let me get something out of the way. If any international students are watching this webinar, this pre-recorded webinar, the wireless embedded systems and the data science engineering programs are part-time only, so they would not be able to sponsor an international student who would require a student visa to study in the USA. Those are only available students enrolled in full-time degree programs. So the wireless embedded and data science cannot support an international student who needs a visa, the AESE program is considered a full-time degree program, and it would be able to sponsor a student who would require a student visa. So with all the programs, we are looking for people with a quantitative backgrounds. So we are looking for degrees in engineering, science, mathematics, physics, for examples. UCSD's typical requirement is a minimum of a 3.0 undergraduate GPA, but we make exceptions every year. If you believe you are a strong candidate for the programs based on your professional experience, your degree, but you have a GPA under 3.0, I would encourage you to reach out and have a discussion with us. Don't automatically eliminate yourself if you don't meet that requirement. We do not require the GRE, and we do not require TOEFL if you are working in the US for more than a year. For the ASE program, the admissions committee typically are looking for individuals with 5 years of relevant work experience. For the West and the DSE programs, typically we're looking for at least 2 years of relevant work experience. There are always, with everything in life, some exceptions, but generally, these are the requirements that faculty admissions committees will look for in the applicants. We have 2 application deadlines. April 30th is early consideration. And what that means is all fully completed submitted applications by April 30th will get a review, and we will give feedback to students about whether or not we feel they are potentially viable for the program or not. The reason we do this is because some individuals are applying to more than one program and want feedback as to whether or not this is a feasible program for them to enter. Our final application deadline is June 30th. At that point, all the applications will be reviewed, and then final decisions will be issued after that point. Typically, that's going to take us probably 4 to 6 weeks after the June 5th deadline, by the time all the admissions committees can review all the applicants and we can get the decisions out to individuals. You may apply to more than one program, and veterans can request a fee waiver. If you have questions about either of those, please feel free to reach out to us. Program schedule. Generally speaking, the baseline is our classes are on Fridays and Saturdays every other week. Every program has slight variations on that, but the basic guideline is Friday and Saturdays all day for our programs. The ASE program is a 1-year program. It is full-time in an academic sense, which allows them to issue a degree after 1 year. That's also why they can support an international student. But it's part-time in the sense that you are able to keep your full-time job and do this degree. It is 4 quarters. UCSD is on a quarter system, not a semester system. So the ASE program is fall, winter, and spring, and then final capstone project is in the summer. The wireless embedded system is a 2-year program. In the first year, classes are only on Saturday, including the summer. The second year, classes are on Friday and Saturday. The DSE program, part-time, 2 years. Classes are on Friday and Saturday, first year and second year, no summer class. An important thing to note is that we record all the classes and make it available to students within a few days of class. So in the case of an illness or unexpected business travel, you will not miss the class. You will still be able to watch the lecture and participate in the class. Cost. So one of the unique characteristics about our program is it's an all-inclusive cost. When you look at the price of other programs, often they will only give you tuition, but that does not include anything else. As you can see from the slide, the ASE program is $33,000, the West is $38,500, and the DSE is $41,000. That's a rounding estimate. We won't know the final numbers until the state of California does its final budget allocations. But it's important to know it's in that cost is your tuition, your books, software, the mandatory UC graduate student fees. We provide breakfast and lunch on class days and parking on campus. So that cost is truly your all-inclusive cost, no additional cost to pursue this degree. Not included is a mandatory healthcare coverage, but you can waive that if you can show proof of other health insurance. And 99.9% of our students have healthcare coverage from their employer, so they waive this. Traditionally, all of UCSD has the same payment plan, which is pay by quarter. Usually the tuition is due 3 weeks before the start of each quarter. Unique to the MAS degree programs is we actually have some payment plan options which coordinate with how different individuals are reimbursed from their companies for participating in the program. So if you go to our website, we have a lot of information about the programs there. There's details for each program. There's an overview. There's a course calendar for that specific program, so you could see when classes would happen. You can see over the whole 1 year or 2 year. There's bio information about the faculty who teach in the program. There's more information on the curriculum and what's covered in the courses. Admissions page will let you know more specifics about what's needed if you decide to apply. There's a cost page which has a breakdown for what the costs are for the program, and there's resources which include an FAQ. So a lot of information there on the website to help answer your questions about the programs. So now I'd like to start talking about some of the specific programs. So the first of the 3 programs that I'll talk about is the Architecture-Based Enterprise Systems Engineering. So the focus of this program is developing systems thinking, which I'll talk about more in a moment. So the founding director of the ASE program is Professor Hal Sorensen, and he is also currently director. And the other co-director is Carlos Combra, who's chair of the MAE department. The ASE is a joint between the Mechanical and Aerospace Engineering and the Rady School of Management. And the intended audience are engineers with 5+ years of relevant professional experience. So just a brief background about why UCSD decided to create this program. The founding director, Professor Hal Sorensen, has been both a respected academic and a corporate executive. One of the things he observed in leading technology teams is that systems engineers were good at building traditional siloed systems, but often far less effective in developing enterprise systems. It wasn't because they were excellent system engineers, it was because they were lacking some critical skills and expertise which he felt the right kind of graduate degree could prepare them for better success. So enterprise systems, by definition, require an understanding and buy-in from many different constituents, the whole ecosystem of an organization, often with different and competing demands on people and resources, which can often be separate from the actual systems themselves. Enterprise systems rarely follow a simple waterfall or linear flow like a traditional siloed system. Consequently, an enterprise system has to incorporate many more feedback loops to be successful. And there's a unique aspect to developing architecture for an enterprise system. So we use an enterprise modeling language to build the architecture, and we use a systems model rather than a software model. So in order to accomplish the learning model, the founding director that said, we need a new approach to systems engineering. It needs to be a collaboration between the engineering school and the business school, because it needs to draw on expertise from both realms. You need the business and the engineering to drive an enterprise systems. As this degree has evolved over the last 10+ years, he's come to refer to this more as the Architecture-Based Enterprise Systems Thinking and Leadership Program. So as new technologies have entered the realm in the last couple of decades, there's a desire for organizations for these to interact with each other. And so an enterprise system often is a system of systems. So what we're doing in the ASE is helping develop the skill sets to integrate these previously unconnected systems and interoperation to accomplish previously unavailable tasks. So get you an understanding about what you will learn in this program. Again, it's a 1-year program, basically 3 core quarters. The fall quarter, the first quarter, is about systems thinking. And it's when we bring in a lot of the business school concepts around strategic planning, leadership, finance and accounting, operations, but then we'll also start looking at how we do agile development and DevOps. We move into the winter quarter, and we move exclusively into the engineering side, and that's where we start to build the architecture. We use domain modeling, we start to do service-oriented architecture, we look a little bit at enterprise cybersecurity, functional and physical architectures, and then measurements of effectiveness and performance. So then we move into the spring quarter. We've got this architecture, and now we start looking about how we do decision modeling. We look at data analytics and big data to help understand how that might drive our decision making. We look at net option value and stakeholder relationships, which loops back to that first quarter when understanding the goals, strategy, finance, because those are people who are decision makers in an enterprise system. We use a lot of different tools, concept maps, Petri nets, data analytic tools. So you'll learn a lot of useful tools throughout the program as you go through. So enterprise systems and systems are complex adaptive systems. So we have approached a unique learning model for this program, and there's a reason that we keep this within a one-year program, is what's called the 70-20-10 learning model. From day one, you'll be put on teams, and throughout the year, there's a significant emphasis on teams and teamwork to work through the ideas. So the idea of this is learning is that 10% is coming from the coursework. That's where the basis is set, but then we move into in-class breakouts. So it's difficult for anybody to sit in a class for 8 hours for the student and the faculty. So there will be lectures. We will move into breakout rooms, work on projects, come back into the classroom. So there's this flow that happens through this process. And then the teamwork is where sort of the rubber meets the road. Those concepts, those ideas are actually worked on in creating a project to go forward. So development model is in the classroom, you define the project that you're going to work on. In that class breakouts, you start defining the capabilities of what your project is going to look like. And then through that team project, you actually develop an architecture, which then you will present in a final capstone at the end of this year. So developing systems thinking capabilities, the learning outcomes of this degree program is basically to understand the enterprise landscape and involve the enterprise stakeholders. What are the issues relevant, important to be able to drive this enterprise system through the enterprise? We start to define a goal and a mission, including a strategy, an operational concept. Then we identify desired capabilities. We consider different alternatives to achieve what we're after, and we start to create some process models, some use cases. We then develop our architectural models. We verify the logic, the behavior, we do some performance modeling. We emphasize events and decision-making, and then we iterate. We look at the considerations, we look at experimentation and experience. And in this process, we become leaders and team builders. So that's what we're doing in the ASC, combining our business concepts and our engineering concepts and our architecture modeling to develop an enterprise system. It's structured for working professionals. So this one's unique. So it's a one-year program from September to August. Classes are scheduled on Fridays and Saturdays every other week. 1 week per quarter. There's a Wednesday through Saturday workshop. Classes are 8 to 5, and we provide breakfast and lunch for you each day. Each class is 32 contact hours. What's unique about this one is that the classes are sequential, not concurrent. So you go to class, 2 class weekends, complete a class. 2 class weekends, complete a class. 2 class weekends, complete a class. And then there's a final 4-day team project class at the end of August. There is a distance learning option available. So if part of your team are not physically in San Diego, there's an opportunity for them to participate in the program. For more details, feel free to reach out and we can tell you more. What we're looking for is the profession's position of a strong engineering, science, mathematics degree. Undergraduate GPA 3.0, again, don't eliminate yourself if you feel like you're a strong candidate because you don't have that. We are looking typically 5 years of relevant work experience. We do want an informative resume. Don't be afraid to elaborate. Give us a couple pages, 3 pages. We really want to know what you've been working on in your projects. And we want 3 letters of recommendations. And we really want people that know you well. So often we get, does this need to be an academic? In most cases, if you've been out of school for 5 years, you probably don't have a relationship with academics anymore. So it's fine if those are coming from people at work who know you well, can really attest to your abilities and your skills. So that is the ASC program. So the next program is Wireless Embedded Systems. So this is a joint program between the Departments of Electrical and Computer Engineering and Computer Science and Engineering. The two faculty directors, Professor Ryan Kastner and Fred Harris, each come from those two departments. And the attendant audience are engineering professionals with a background in computer science and or electrical engineering. So why a wireless embedded systems degree? So I don't like hyperbole, but it really is kind of a wireless revolution with right now they're estimating 24 billion wireless devices. There's 4 devices for every person on the planet, and that's only going to grow. With the advent of 5G, there'll be that many more wireless connected devices. And what's unique about this program is that this wireless embedded system is inherently interdisciplinary, understanding the boundary between electrical and computer engineering. So there's trade-offs between the hardware and the software capabilities when you're designing an embedded system. And as we look at designing the next generation of these wireless devices, from toasters and coffee machines to cars, things we have to look at are form factor, cost, power consumption, and these need to be dramatically lower than existing cellular phones. So designing these systems requires an understanding of systems, software, hardware, and communication theory, which is exactly what we're doing in this degree program. Just to let you know more about what the curriculum includes. From the computer science side, embedded systems design, software for embedded systems, and hardware design for embedded systems. From the EE side, digital signal processing, digital communication systems, and then wireless communication systems. So this is going on in your first 1.5 years of the program. And then in your second year, in the winter quarter, you start working on capstone projects. You're starting to design and think about them over the summer. Sometimes students do these as a team. Sometimes students do it as a solo project. But this is where these two disciplines come together, where you validate and prototype an embedded system, which you deliver as a final capstone project. You deliver it to your faculty, and you deliver it to your classmates. So how does this look on an academic calendar? As a reminder, the classes across the top the first year are on Saturday only. On the second year, they're on Friday and Saturday. So we start with digital signal processing, and then we build through the first year more about the embedded systems and the wireless. Second year, we actually start getting into the validation and prototyping of these systems, which then rolls into the capstone project. Typically, the students coming into the program either have the computer science or the electrical engineering. So students typically partner up with the person that comes from the other discipline from their expertise. So the computer science will pair up with the EE and the EE with the CS to help fill in the gaps in the classes where it is taxing your knowledge base because it's not your comfort zone. So it's a very academically rigorous program, but students help each other to get through this program, and there's great interaction with TAs, TA sessions to help you move through the program. What we're looking for is people with a degree in computer science or electrical engineering. And really, typically, you need to have one of those expertise and then the real world experience applying that in the workplace. Look for a GPA 3.0. Again, if you feel like you have a good academic background and a foundation, I should say maybe, and really relevant work experience, and you have less than 3.0, don't rule yourself out. Talk to us. Statement of purpose. Why do you want to do this program? Tell us why this program, why now? How does this fit into your professional goals and aspirations? 3 letters of recommendation. Because students have been out of school for a while, typically they don't have an academic recommendation, they have them professional. Professional should come from people who can really attest to your knowledge of what you're working on, what you're doing day to day. We don't require GRE, but typically we want at least 2 years of relevant experience. And relevant is key here, is that you are working on something that is directly relevant to an aspect of the wireless embedded degree. All right, the final program we'll talk about is data science and engineering. The DSE program is a joint program between the Computer Science and Engineering Department and San Diego Supercomputer Center. The two faculty directors are Dr. Ilke Altintes from the Supercomputer Center and Professor Aline Deutsch from the Computer Science and Engineering Department. The intended audience of this program are engineering professionals with a background in computer science or other engineering or mathematics with substantial experience in data analysis. The measurement of what constitutes big data is changing rapidly, and with the advent of 5G, it will expand even more rapidly because of the ability to connect even more devices at once, producing incredible amounts of data. As I mentioned in the wireless embedded systems overview, we already have 24 billion connected devices, and that number increases daily. Everything from smart speakers to our refrigerators are now generating retrievable data. If you look at a technology timeline, the exponential growth of data capacity is incredible. This slide here is simply computer PCs. When you extrapolate this to something like Amazon Web Services, the amount of data capacity today and what we'll have in 5 years is difficult to grasp. We've already named the next 9 iterations of data capacity. So gigabyte, terabyte, petabytes are already in our lexicon. We're starting to add exabyte because there's an exabyte of data created by the internet every day. But we'll be talking about zettabytes and yottabytes, rontobytes and geobytes before you know it. So data science is the blending of 3 distinct areas of expertise: computer science to access the data, math and statistics to analyze the data, and domain expertise to know its relevance in decision-making. By domain expertise, I mean specific areas where data science might be applied: real estate, finance, medical research. From an academic perspective, historically, data science has lived in the computer science departments because you needed the computer programming skills to access the data in the first place. But as the field of data science has expanded, our DSE program with its interdisciplinary approach is uniquely positioned to bring these 3 necessary disciplines together. The focus of our program really is centered on the top 2 circles. We combine the computer science skills to understand how to effectively and efficiently access large and disparate amounts of data with the math and statistical skills to understand the validity of our data analysis. You can't master all 3 spheres in a 2-year program, so we aren't going to make you domain experts, but we do teach students how to present your research in ways that non-data scientists can understand. So the coursework. So the program is a 2-year program with classes on Friday and Saturday every other week for the 2 weeks, no summer class. Laid out here, you can see what the courses are. We start with Python for data analysis and case studies, in which we bring experts working in the field of data science to better understand the applications. And then we start moving into the probability, the math statistics, the data management, machine learning, and data science using Hadoop and Spark. Groups start to form their ideas for their capstone over the summer and return in the 2nd year, start doing classwork, and then the capstone starts in the winter quarter, and that is the exclusive domain, and the last quarter is doing the capstone. A note on the program, as I mentioned in the introduction, because this data science program is a part-time only, international students who would require a student visa to study in the US are not able to enroll in this program. Student visas are only available for students enrolled in full-time degree programs. So what we're looking for, what the admissions committee are looking for of major importance in your experience and your background is programming experience in a general purpose language: C, Java, Python. Experience with databases in SQL. 3, experience with data analysis in an application domain. So really we're looking for at least 2 of these 3. Minor importance, but strengthens your application, is a good background in math, linear algebra, probability of statistics, and experience with distributed systems, Hadoop and Spark. So faculty are typically looking for at least 2 years of relevant professional experience. I will say over the last couple of years, the profile of the class has typically been more in probably the 5 to 8 years of relevant professional experience. We have a large number of applications for the program, and so faculty are able to pick people who have really strong professional backgrounds in these areas. So that is the data science program. Next steps, please go to our website. A lot of information there to help you understand more about the programs. The application system is open now. You can start the program, start the application program process now. If you have questions, you can email us. We are happy to schedule phone conversations with you, a Zoom call. And please sign up to join one of our upcoming live Q&A webinars. Well, as I said, we'll have faculty. I'll try to get some alumni. And you can ask them more specific questions about the course, the content, the faculty, whatever may be on your mind. So we hope to have you in our classes in the fall. Thanks for participating.